Section 15, question 1. A sector of a circle, centre O, is shown below. The radius of the circle is 2.3 metres. The angle AOB is 65 degrees. Find the length of the arc AB. The way you should interpret this question is we're basically looking for the bit of a circumference of a circle. Which is the bit? It's 65 degrees out of 360. So for length of arc, it's equal to 65 out of 360 lots of the circumference, which is pi d. So 65 out of 360 times 3.14, or the pi button in your calculator, times the diameter. Now if the radius is 2.3, we can quickly say that the diameter is 4.6. So at that point, just enter into your calculator 65 out of 360 multiplied by 3.14 multiplied by the diameter, which is 4.6. Now it's a length we're looking for, so the units are is metres, and that's to one decimal place 2.6 metres. That's the end of the question. Section 15, example 2. A circle, centre O, has radius 36 centimetres. Part of the circle is shown, and the angle AOB is 140 degrees. Calculate the length of the arc AB. So the length of the arc is again a bit of the circumference of the circle, and the bit is 140 degrees out of 360. So the length of the arc is equal to 140 out of 360 lots of the circumference, which is pi d. So that's 140 out of 360 lots of 3.14 multiplied by the diameter. So the radius is 36, the diameter will be 72. So 140 out of 360 multiplied by 3.14 multiplied by 72. I'll just repeat that line. So we can enter this into the calculator now. So 140 divided by 360 multiplied by 3.14 multiplied by the diameter, which is 72, and to one decimal place, that's 87.9 centimetres. That's the end of the question. Section 15, example 3. A cone is formed from a paper circle with a sector removed as shown. The radius of the paper circle is 30 centimetres. Angle AOB is 100 degrees. Calculate the area of paper used to make the cone. So this is the amount of paper here. Now we can see that this angle in here must be 260 degrees by taking 100 away from 360 the full turn. So the angle in here for the major arc is definitely going to be 260 degrees. Now to find the area, that's basically this surface in here. Now it's a big part of a circle. The area of a circle is pi r squared, so it's basically 260 degrees out of 360 degrees of a circle. So the area of the sector is going to be 360 lots of pi r squared. So it's going to be 260 out of 360 multiplied by 3.14 multiplied by the radius squared, and that's 30 squared. So I can enter that into the calculator now. And that will give me 2041 square centimetres. Remember that square units for an area. Part B says calculate the circumference of the base of the cone. So we're looking for this here. Now if you think about it, the net of that shape, if it's folded up, then the circumference will be made from this bit here. If we fold this bit and this bit up, the circumference of the circle on bottom will be given by that. So that's basically the length of the arc. So remember, it's 260 degrees again. So the circumference of the base of the cone will be given by the length of this arc. So the length of the arc is basically a bit of the circumference, so 260 degrees out of 360, lots of pi d. So coming across here, 260 out of 360 times 3.14 multiplied by the diameter. Now the radius is given by 30, therefore the diameter will be 60. Just to enter that now into the calculator. So 260 out of 360 times 3.14 times the diameter 60, and that's 136.1 centimetres to one decimal place. I'm not going to square the units because it's a length, not an area. That's the end of the question.